Hi, good afternoon, students. How are you? I hope all are fine at home. Okay, it is the last class in our first chapter, rational numbers. Representation of rational numbers on the number line. We already discussed about the topic, but in this class we discussed about some negative rational numbers. Okay, consider -1/2. First we partitioned the space between -1 and 0 between two equal parts because the denominator is 2. But one thing, in the case of positive rational number we partition the portion between 0 and 1. But in the case of negative rational number we partition the portion between -1 and 0. Then we get two equal parts between 0 and -1, 0, -1/2, -1. Then we can easily represent -1/2. Okay, now the another example, consider -2/3. The denominator is 3. Then how can we represent? We equally partition between 0 and -1 into 3 equal parts because the denominator is 3. Then we get 0, -1/3, -2/3, -3/3, -4/3. -3/3 means -1. Then we get the position of -2/3. We can easily represent at that position. One thing, if you consider a positive rational number, we partition the portion between 0 and 1. In the case of negative rational number, we partition the portion between 0 and -1. Isn't it? Rational numbers between two rational numbers. It is a new topic. Now let's see how many rational numbers between 3/10 and 7/10 is a question. How many rational numbers between 3/10 and 7/10? The denominators are same. Then what's the next rational number 3/10? 3/10, 4/10, 5/10, 6/10. The next one is 7/10. Then we get three rational numbers between 3/10 and 7/10. It's only three rational numbers between 3/10 and 7/10? No, because we can write 3/10 as 30/100. Because if we cancel the last zeros, it's same as 3/10. 3/10 is equal 30/100. And also 7/10 is equal 70/100 because if we cancel the last zero, it is equal 7/10. Then how many rational numbers between 30/100 and 70/100? More than 3. Then we get 31/100, 32/100, 33/100 up to 69/100. Then what is the next 69/100? 70/100. In that way we can write 3/10 as 300/1000. Okay, 300/1000 is equal 3/10. And 7/10 is equal 700/1000. If we cancel the last two zeros, we get same as 3/10. In the same way, we cancel the last two zeros, we get 7/10. In that way, we can found more and more rational numbers between 3/10 and 7/10. Then we get countless rational numbers between any two given rational numbers. Once more, the denominators are same. Convert 3/10 and 7/10 into more large numbers. Then we get more rational numbers between in these two rational numbers. Is that concept? Okay, now we can discuss some problems about rational numbers between rational numbers. It is a sixth example in your textbook. Write any three rational numbers between -2 and 0. It's very simple. -2 can be written as -20/10 and 0 can be written as 0/10. -20/10 means -2 because 20 has 10 2 times, put a negative sign, it's same as -2. Then we get -19/10, -18/10, -17/10 up to -1/10. What is the next? 0/10. Then we can choose any three of these. One more. We can return as -2 as -20/10. We cancel the 0 in the numerator and denominator. We get -2/1 same as -2. In that way we can find more rational numbers between -2 and 0. Then the next question, find any 10 rational numbers between minus 5 by 6 and 5 by 8. Is the question. Find any 10 rational numbers between minus 5 by 6 and 5 by 8. In this question, the denominators are not same, 6 and 8. Then how can find? We take the LCM of 6 and 8 from these two rational numbers. Consider 6 and 8, which is the least prime number 2. 6 has 2 3 times, 8 has 2 4 times. That way, 3 has the next, consider the next prime number 2. 3 has 2 not times, then we write the same number, then 4 has 2 times. We get the LCM of 6 and 8. 2 into 2 into 3 into 2, 2 into 2, 4, 4 into 3, 12, 12 into 2, 24. We get the LCM of 6 and 8 as 24. Okay, then first we convert the denominators into the same denominators. It means if we divide 24 by 6, what do you mean by 24 by 6? 24 by 6 is 4, and we multiply with the numerator and denominator with 4. Minus 5 into 4, we get minus 20. 6 into 4, 24. The same way, 24 by 8, we get 3. We multiply with 3 with the numerator and denominator. 5 into 3 as 15. 8 into 3, 24. Once more, we take the LCM of the denominator 6 and 8. We get 24. 24 by 6 is 4. 4 into minus 5 is minus 20. 6 into 4 is 24. In the same way, 24 by 8 is 3. 3 into 5 is 15. 8 into 3 is 24. Then we get minus 19 by 24, minus 18 by 24 up to 15 by 24. We get more than 10 rational numbers between minus 5 by 6 and 5 by 8. One thing, if the denominators are not same, we take the LCM of that numbers, then we divide the denominator 24 by 6. In that same number we multiply the numerator and denominator, we get the same denominators. Okay. In this case, minus 5 by 6, the LCM is 24. 24 by 6 is 4. Then we multiply both numerator and denominator with the 4. We get minus 20 by 24. 24 by 8 is 3. And both multiply with the 3. 5 into 3 is 15. 8 into 3, 24. We get more than 10 rational numbers between minus 5 by 6 and 5 by 8. Okay, then the next one is find a rational number between 1 by 4 and 1 by 2. A rational number means one rational number between 1 by 4 and 1 by 2. Then how can find? The denominators are not same. Then we take the LCM of 2 and 4. We get 4. Then 1 by 4 is not changed, 1 by 4. And 1 by 2 can be written as 2 by 4. It's same as 1 by 2 as 2 by 4. Then 1 by 4 and 2 by 4. If you can find a rational number between 1 by 4 and 2 by 4, it is not possible. Then we multiply both numerator and denominator with 2. We get 1 into 2, 2, 4 into 2, 8. We get 2 by 8. In that same way, we multiply with the numerator and denominator in the second rational number. 2 into 2, 4. 4 into 2, 8. We get 2 by 8 and 4 by 8. Then we get 3 by 8 between these two rational number, 2 by 8 and 4 by 8. Once more, in this rational number, the denominators are not same. Then we take the LCM of both 4 and 2. We get 4. Then 1 by 4 is equal 1 by 4 and 1 by 2 is equal 2 by 4. By LCM, 2 by 4 is equal 1 by 2. Then we cannot find a rational number between 1 by 4 and 2 by 4. Then we convert or multiply numerator and denominator with 2. We get 2 by 8 and 4 by 8. We can easily find a rational number between 2 by 8 and 4 by 8, 3 by 8. Find 3 rational numbers between 1 by 4 and 1 by 2. It is same as in your previous slide, but in this case we find 3 rational numbers between 1 by 4 and 1 by 2. Then how can? Okay, consider an example. Consider any two integers 1 and 3. Then how can find a number between 1 and 3? mean average method. It means if we add these two numbers then divided by 2, it means 1 plus 3 by 2. 1 plus 3 is 4. 4 by 2 we get 2. 2 is lies between 1 and 3. It is known as mean average method. Or if we add these two numbers and divided by 2, then we get the middle number of these two numbers. In that same way, if we consider 1 and 2, 1 is the first number and 2 is the middle number. 1 plus 2 by 2, 1 plus 2 is 3. 3 by 2 means the half of 3 is 1.5. Then 2 and 1.5 are also less between 1 and 3. Once more, in these two cases, if we add the two numbers and divided by 2, we get the middle of 1 and 3. In that same way, if we add the first number and this central number or middle number is 2, 1 plus 2 is 3, 3 by 2, 1.5. It also lies between 1 and 3. In that same way, if we add the next two numbers, 2 plus 1.5 by 2, 2 plus 1.5 is 3.5 by 2, 1.75. It is also lies between 1 and 3. In the all cases, these numbers are lies between 1 and 3. Okay, now in this question, we find three rational numbers between 1 by 4 and 1 by 2. In the same way, we can find the middle of the rational number. We already found the middle number between 1 by 4 and 1 by 2 is 3 by 8. In your previous slide, we already found that the middle rational number between 1 by 4 and 1 by 2 is 3 by 8. Then, in these two rational number 1 by 4 and 3 by 8, then we can find another middle rational number between 1 by 4 and 3 by 8. Then how can we add these two rational number and divided by 2? Mean average method. 1 by 4 plus 3 by 8 by 2, we get the central. We can now see that. Consider 1 by 4 and 3 by 8. 1 by 4 plus 3 by 8. 1 by 4 plus 3 by 8, the denominators are not same. Then we convert the denominators, by LCM method, we get the denominator as 8. The LCM method, we get the LCM of 4 and 8 is 8. Then 8 by 4 is 2, 2 into 1 is 2, 2 into 4 is 8. When we get 2 plus 3 by 8. 2 plus 3 is 5, 5 by 8 by 2. How can divide by 2? By multiplicative reciprocal. The multiplicative reciprocal of 2 is 1 by 2. 5 by 8 into 1 by 2. 5 into 1, 5. 8 into 2, 16. Once more, if you find out the middle rational number between 1 by 4 and 3 by 8, we add these two rational number and divide by 2. 1 by 4 plus 3 by 8 by 2. 1 by 4 plus 3 by 8. The denominators are not same. By LCM method, the LCM of 4 and 8 is 8. 8 by 4 is 2. We multiply both numerator and denominator. 2 into 1, 2. Then 2 plus 3 by 8. 2 plus 3 is 5. 5 by 8 by 2. It's not possible by divided 2. Then we can multiply with the multiplicative reciprocal. The multiplicative reciprocal of 2 is 1 by 2. 5 into 1, 5. 8 into 2 is 16. We get 5 by 16 is the middle of 1 by 4 and 3 by 8. In that same way, we can find the another rational number between 3 by 8 and 1 by 2. Okay. If we add 3 by 8 plus 1 by 2 and divided by 2. We get 3 by 8 plus 1 by 2. How can I add 3 by 8 plus 1 by 2? The denominators are not same. The LCM of 8 and 2 is 8. Then 8 by 2 is 4. 4 into 1 is 4. 3 plus 4 by 8 by 2. It's average method, mean average method. 3 plus 4 is 7. 7 by 8 by 2. It's not possible. Then we multiply with the multiplicative reciprocal of 2. Multiplicative reciprocal of 2 is 1 by 2. 7 into 1 is 7. 8 into 2 is 16. We get another rational number between 3 by 8 and 1 by 2 is 7 by 16. Then we get 3 rational number between 1 by 4 and 1 by 2 as 5 by 16, 3 by 8, 7 by 16. Once more, we find out more rational numbers in this method. First, we consider the first two rational number 1 by 4 and 1 by 2. If we add 1 by 4 plus 1 by 2, we get this central or middle rational number 3 by 8. In that way, if we add these two rational number 1 by 4 plus 3 by 8, then divided by 2, we get the another rational number between 1 by 4 and 1 by 2 is 5 by 16. That same way, if we add 3 by 8 plus 1 by 2, we add these two rational number, then divided by 2, we get 7 by 16. In that way, we can find more rational number. We can choose any way. Okay, now in this question, we can find the answer in another method. We can easily find 3 rational numbers between 1 by 4 and 1 by 2. We take the LCM 4 and 2, we get 1 by 4 as 1 by 4 and 1 by 2 as 2 by 4. The denominators are same, 1 by 4 and 2 by 4. Then we multiply both numerator and denominator with 10, we get 10 by 40, and the second case we get 20 by 40. Okay, then we can easily find out rational numbers between 10 by 14 and 20 by 40. What are the rational numbers? 11 by 40, 12 by 40 up to 19 by 14. We get easily more than 3 rational numbers. Okay, you can take any 3 of this. And the next one is find 10 rational numbers between 3 by 5 and 3 by 4. In this case, the denominators are not same. Then how can find? We take the LCM of 5 and 4. The LCM of 5 and 4 is 20. Then 20 by 5 is 4. 4 into 3 is 12. We get 12 by 20. Then it's equal 120 by 200. Because if we cancel by zeros in numerator and denominator, we get 12 by 20. It's same as 3 by 5. In that way, we can convert 3 by 4. 20 by 4 is 5. 3 into 5 is 15. 15 by 20. It is same as 150 by 200. In that way, we can find more than 10 rational numbers between 120 by 200 and 150 by 200. These are some examples: 121 by 200, 122 by 200. In that way, we can find up to 149 by 200. Once more, if the denominators are not same, we take the LCM of these two numbers 5 and 4. Then the LCM of 5 and 4 is 20. 20 by 5 is 4. 4 into 3 is 12. 12 by 20 is same as 120 by 200. Then 20 by 4 is 5. 3 into 5 is 15. 50 by 20 is same as 150 by 200. Then we can find more rational numbers between 120 by 200 and 150 by 200. Okay, these are some questions in your textbook. Exercise 1.2. Write 5 rational numbers which are smaller than 2. 5 rational numbers which are smaller than 2. It is very simple. 1 is smaller than 2 and is also a rational number because 1 can be represented as 1 by 1. 0 is also an example. 0 is rational number. -1, -2, -3, -5. These are also an integers and also rational numbers because -1 can be represented as -1 by 1, -2 by 1. In that way, we can find more than 5 rational numbers which are smaller than 2. And the next one is write 5 rational numbers which are greater than 2. 3, 4, 5, 6, 8, etc. These numbers are greater than 2 and also a rational number because 3 by 1. These numbers can be represented as 3 by 1, 4 by 1, 5 by 1. At that way, these numbers are also integers and also rational numbers. And the next one is find 10 rational numbers between -2 by 5 and 1 by 2. 10 rational numbers between -2 by 5 and 1 by 2. In this question, the denominators are not same. Then how can find? We take the LCM of both denominators. If the LCM of 5 and 2 is 10, then minus 2 by 5 can be 10 by 5 is 4. Sorry, 10 by 5 is 2. 2 into 2 is 4. We get minus 4 by 10. Once more, the LCM of 5 and 2 is 10. Then 10 by 5 is 2. Minus 2 into 2 is minus 4. We get minus 4 by 10. Okay, the next one is 1 by 2. Then 10 by 2 is 5. 5 into 1 is 5. 5 by 10. These two rational number minus 4 by 10 and 5 by 10. We cannot find 10 rational numbers. Then we convert both rational number into huge or greater than these ones. Then if we multiply both numerator and denominator with the 10, minus 4 by 10 as minus 40 by 10. It's equal minus 4 by 10 because if we cancel the zeros in numerator and denominator, we get same as minus 4 by 10. At that way, 5 by 10 is equal 50 by 100. Once more, the rational number between minus 4 by 10 and 5 by 10 is not included in 10 rational number. Then we convert these two rational number into greater. Then minus 4 by 10. If we multiply both numerator and denominator with the 10, we get minus 40 by 10. At that way, 5 by 10 as 40 by 100. 5 by 10 as 50 by 100. Then we get rational number between minus 40 by 100 and 50 by 100 are minus 39 by 100, minus 30 by 8 by 100. At that way, 49 by 100. We get more than 10 rational number between minus 2 by 5 and 1 by 2. We can choose any method. If the denominators are not same, first we take out the LCM of both the denominator, then convert into same denominators. Then we convert the huge or great rational numbers. Then we can find easily more than 10 or more than rational numbers between two rational numbers. Hi dear students, in this class we discussed about rational numbers between rational numbers. We can choose any two method. First method is mean average method. We add two rational number, then divided by 2, we get the middle rational number. At that way we can find more than rational number. Or another way is, if the denominators are not same, we take the LCM of both numbers and convert into same denominator, and it should be converted into more greater number. We can easily find out more rational numbers between two rational numbers. Okay dear students, if you have any doubts, please contact me personally.